Welcome to the 6-4 notes on AA similarity. So what is 6-4 about? And so to kind of get context for this, you don't have to write this down. I'm just going to go to the, other page, the back of this page for a second here. Let me just remind you what we did in chapter 4. So if you remember, chapter 4 was all about congruent triangles, right? Chapter 4 was all about congruent triangles, and again, that means that the triangles are going to be exactly the same size and exactly the same shape. So like if this was like 6, 7, and 8, this would have to be 6, 7, and 8. And all the angles would also have to be congruent, right? Congruent means all the sides and all the angles are exactly the same, right? But if you remember from chapter 4, we didn't actually have to prove all the sides and all the angles congruent to say the sides were congruent. We actually learned some shortcuts. Okay, so if you remember, one of them was that if I know just the sides, side, 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 right? There could be numbers or not. If the sides are the same, that would force the angles to also be the same. And so I don't need all this information. I could just say if I have all three sides, S, 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 congruent, then I could say that the triangles are congruent. Likewise, if I had SAS, right, if I have two sides and the included angle congruent, that would mean that these are congruent, even without all this information. And we'd had other ones like ASA, and we had AAS, and we had HL. So those were the 5 shortcuts from chapter 4 to prove triangles congruent. What we're going to do today is kind of do the exact same thing, except we're going to do this for chapter 6. We're going to talk about how can I prove things similar, right? How can I prove things similar? And remember, if two triangles are similar, that means their corresponding angles are blank and their corresponding sides are blank. What do you think that means? What does it have to be? Do you remember? So corresponding angles have to be still congruent, right? So still the same shape, but the sides are going to be different. They're going to be, at least, they have to be proportional. Proportional, right? Angles congruent, sides proportional. Now, if you remember back from the previous lesson, before, if I wanted to prove two polygons were similar, I had to show that all of the sides and all of the angles were congruent. Let me just show one from last time. Right, so we had to check all of the angles, and we check all of the sides, and then we could say they were similar, right? But just like chapter 4, like I did on the back here, with congruent triangles, I have a shortcut to prove things similar, and that is called AA. AA. And let's put AA similarity, a little tilde there. So what does AA similarity mean? Why don't we go to our theorem sheet to write down what does that mean? Okay, so our theorem sheet. So AA similarity postulate. AA similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then they must be not congruent but similar. Okay, so it's just like the other shortcuts. I don't need to have all the information. Look, I don't have anything with the sides given or anything like that. If I just have an angle and angle, I can say that these must be similar. Okay, so let's think about why that makes sense. So I think I have a link posted, but I'll just show it here as well. So let's say I've got 39 degrees and 30 degrees. 39 degrees and 30 degrees. Actually, let me make it 40 and 30, just make it a little easier. So 40 degrees, 30 degrees. Notice how I've got congruent 30, 30, congruent 40, 40. That is enough. I don't actually, I could cover up this, 2.4. It's enough just to have these two angles congruent. Let's think about why just two angles. Like, why don't I need AAA? Why is 2 A's enough? Why don't I need all 3 angles? Well, if you think about it, if you have 2 angles, right, if this is 30 and 40 degrees, that's 70 degrees total, doesn't this one have to be 110 degrees because of the triangle angle sum theorem? Right, this would have to be 110 degrees, and likewise, this angle E would also have to be 110 degrees, excuse me. So, that right there since the angles are going to be congruent, when I have two angles, I actually have all three angles congruent, right? Because of the third angles theorem, these third ones also have to be congruent. And then you could see that pretty much if all three angles are congruent, then you're going to have the same shape, right? So if you look at this, look, it's the sides are proportional. This to this is 1.36. This to this is 1.36. This to this is 1.36. And I can change this. Look, I can make this one bigger, blah, blah, blah. See how the numbers are changing. Look, the ratios are changing now. It's almost twice as big. In fact, I can make it pretty much twice as big. All right, now this is pretty much, this is double this. This is double this. This is double this. But you know what? As long as the angles, you still have AA, the angles are the same, it's going to force everything to be similar. Okay, so the point is, as long as I have AA, and I could change this, right? I could change the angles, but it doesn't matter. It's going to keep these guys as similar. Okay, so now I have a shortcut. I don't have to have all the sides proportional, all the angles congruent given to me. I just need to show two angles congruent. And if I've got two angles congruent, that will force them to be the same shape. Okay, so let's jump back here. Okay, so AA similarity postulate, if I've got two angles, that is enough. You could see it's going to create, it's going to have to be the same shape. All right, so with that, let's go ahead and look at number 1 here. Determine whether the triangles are similar. If they are, write a similarity statement. Remember, that's the thing, like, you know, triangle, blah, 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 similar to triangle, blah, blah, blah. All right, explain our reasoning. So again, let's look, if I could try to use the definition of similar. So the definition says, if I want to show them similar, I got to show all the angles congruent, all the sides proportional. Right away, that's a problem, because look, I don't have any side information. What is this? Is this 10 feet? Is this 5? I have no idea. There's nothing given here, so I cannot use the definition. So we would be stuck, except now we have this shortcut saying, you know what, all I need is two angles from one to be congruent to two angles from the other, and I've got a similar triangle situation. So look, I've got 90 degrees and 90 degrees, that's 1. And then I got 64 and, well, that's 26. But if you think about it, I could find this third one here by using the triangle angle sum theorem. 90 plus 64 plus whatever measure of angle k is must be 180 degrees. Subtract out this 90 degrees, so 64 plus this angle here must be 90. So I can just say 90 minus 64 is going to equal this measure here. 90 minus 64, I'm going to borrow here, so that's going to be 10 minus 4 is 6. That's 26. So right here, this is 26 degrees. And so we can see, yes, I've got 90 and 90. I've got 26 degrees and 26 degrees. So yes, I could say, let me write the similarity statement. Triangle CDE is similar, right? CDE. So I have to match up. Who does C match up with? That would be K, because they're both 26 degrees right there. So CDE, KGH. And explain, why do I know? Even if I didn't have all the sides proportional, because by AA similarity, right? AA similarity says as long as you've got two angles congruent, then the third angle, of course, has to be congruent by the third angles theorem, right? This would be 64 degrees. You know, we could do that as well. This would be 64 degrees. So if all the angles are congruent, it has to be the same shape, and so therefore it's similar. All right. Number 2A. Show the two triangles are similar. Triangle ABE, that's this guy here, and ACD, and triangle SVR and UVT. Why don't you pause the video and see if you can think about why could we say these different triangles are congruent? What reasoning would you give if I was asking you on a test? Go ahead and pause it, see if you can figure it out. All right, so for this, again, just like with the previous problem here, the definition of similarity, all angles congruent, all sides proportional, but I don't have any side lengths, so I can't really talk about the definition. I can't use the definition. The only hope I have is to use AA similarity. So I've got this angle here, so angle B in this little triangle is congruent to angle C in this bigger triangle, right? But that's all, right? We don't have anything else. But if you're looking carefully, you notice that, hey, look, both triangles also share angle A. Angle A from the big blue triangle is congruent to angle A from the smaller black triangle by the reflexive property. So we could say that triangle ABE is similar to triangle ACD by AA similarity, right? You could say, if you want to give a reasoning, you could say this is the reflexive property, right? Angle A is congruent to angle A, okay? And this one over here, all right, why are these guys similar? So SVR and UVT, remember these arrows mean parallel. Hopefully you notice that angle SVR is congruent to angle UVT by vertical angles. And if I have these parallel lines, remember if you get stuck, I think it's highly useful to extend this out so you can see it. You can extend out this transversal as well. And so if you remember from chapter 3, if I've got parallel lines cut by a transversal, then this angle here, angle T, arc, is congruent to this angle here, angle R, by alternate interior angles. If you turn your head, you can kind of see that a little bit easier. Same thing over here. If you want to add this one, arc, angle U is congruent to angle S by alternate interior angles. In fact, you didn't have to add both of those. You could have added either one. So we actually had some choice here. You could have added vertical angles plus one of these guys, or you could have just added the two pairs of alternate interior angles. But in the end, either way, you can say triangle SVR is similar to triangle UVT, again, by AA similarity. Now, number 3. Let's say in this example, this was not parallel. This was not parallel. Could they still be similar? Could I still say that these are similar? Well, if you think about it, if these were not parallel, could I still add the vertical angles? Yes, vertical angles don't depend on these being parallel or not. Now, if these were not parallel, could I add this alternate interior angle here and alternate interior angles here? That answer is no. So if imagine you couldn't add these and these, all you'd have is vertical angles. That's only one pair of congruent angles. That's not enough. Remember, you need two pairs. You need AA. So if these were not parallel, the answer is no, right? No, because you couldn't add alternate interior angles, and then you wouldn't have AA similarity. Okay. All right. So now let's go ahead and try number 4 here. Again, try number 1 and 2 here from number 4 here on your own. Pause the video. Can I call these triangles similar? Can I call these triangles similar? C, D, F, and D, E, F. Go ahead, please. All right, let's take a look. Now, number 1 is kind of tricky. It's kind of mean because if you thought about it, if you looked at it carefully at first, you think to yourself, all right, to be AA, you need this to be congruent to this congruent to this, and you look and you say, hey, arc. So my first thought is, you know what? No, because arc is not congruent to arc, so on and so forth. So that's my first thought is, hey, I got it. I thought about it. The answer is no. They tried to trick me, but actually it was kind of a double trick. It was kind of mean here. They're really quite mean with this. If you think about it though, look at this. Because all 3 of these are marked, we actually know what the measure of angle R is. Because it's a triangle and all of these are the same, doesn't this have to be 60 degrees, 60 degrees, 60 degrees, right? Because they're all the same, they add to 180. Same thing here. All 3 are congruent and it's a triangle. Doesn't this have to be 60 degrees, 60 degrees, and 60 degrees? And so if we look, even though the markings are different, it was quite tricky, we actually do have enough to call these similar. So we can say, yes, triangle FGH is similar to triangle RQS by AA. Okay, let's take a look at this one, CDF and DEF. So again, we try to go with AA. Let's think about this. since this is a 180 degrees straight angle and this is 90 degrees, I can go ahead and add this as being 90 degrees there, because 180 minus 90, this must be 90. So I've got 90 and 90 degrees, that's 1. Let's see if we can figure out the other one by using the triangle angle sum theorem. So I could find this angle here, angle CDF. I know that this is 90 and this is 32. So I'm going to subtract out 90 degrees and 32 degrees from 180. I'll just subtract out the 90, so I'll just say 90 minus 32, right? And that'll give me this measure here. That would be 58 degrees. And so we can stop right there. I mean, you could find this one as well. This would be 32 degrees. But we could see that's enough. I could see that, you know what, because I have two pairs of congruent angles, I can say, yes, that CDF is similar to triangle DEF by AA similarity. Okay, so basically you're just looking for ways, either using vertical angles, parallel lines, shared angles. Maybe you have to fill in the blank here to get triangles congruent. Let's just do one more. Let's go to the back. We'll skip number 6 for now. Let's do number 5. So a flagpole, and hopefully if we have time, we're going to go outside and do an activity similar to this. Similar, get it? Okay. Let's say a woman stands outside and the sun is shining. Now, I don't know about you, but I'm not going to want to climb to the top of this and hang some kind of measuring tape down to measure this. But the cool thing is we can use geometry to calculate how tall this flagpole is. Why can we do that? Because this is dangerous to measure, but the length of this shadow is quite safe to measure, right? You just go along the ground, and this is what we're going to do sometime. This shadow, it says here, is 50 feet long. 50 feet long. At the same time, this woman is 5 feet 4 inches tall. 5 feet 4 inches tall. And her shadow is 40 inches long. Okay. How tall is the flagpole? It's the nearest foot. And first off, it looks like here I'm going to be setting up some kind of proportion, like this to this is this to this, but let's pause here. Why could I say, let's go ahead and just draw a little triangle here. Why can I say that these are proportional? I mean, you can't just make proportions for things that aren't proportional. Can I really say something like this to this is this to this? In fact, the answer is yes. And let's figure out why. Why are these two triangles proportional? Well, first off, they're standing kind of at 90-degree angles here. And then if you think about what is a shadow, it's formed by the sun shining its happy little rays down. That looks like a sun, kind of. Looks kind of creepy, actually, but whatever. Pretend it's the sun. And it's super far away. So far away, in fact, that even though you're not quite standing in the exact same place, this angle here from super far away is going to be pretty much congruent to this angle here. The difference is negligible because the sun is so far away, right? So if you think about it, look at this. You've got angle, angle. So because by AA similarity, this triangle is similar to this triangle. So therefore, yes, I know the sides are proportional. I can make some kind of proportion. This to this is equal to this, or this to this equals this to this. Proportions, again, can be ratios or rates. So in fact, I don't even have to change everything necessarily to feet. I can mix the units if I want, as long as I keep it consistent. But this 5'4" is kind of problematic. So let's switch 5 feet 4 inches. 5 feet 4 inches into just one thing here. Let's convert that to inches, right? So again, let's convert 5 feet into inches. Since we know that there is, in 1 foot, there is 12 inches. Again, each one of these, there's 5 of these. I'm just going to multiply by 12, right? Just multiply this by 12. If you really want to see how that works again, what you do is you multiply 5 feet by either 1 over 12 or 12 over 1. Because there's equivalent, that just becomes an equivalent form of 1 here. But we want to put the 1 that's going to cancel out on the bottom, right? So I want to put 12 inches over 1 feet, and I can have feet and feet cross off. I'm left with 5 times 12 equals 60 inches. Okay, so this is 60 inches. 60 inches plus 4 inches. So this woman is 64 inches tall. 64 inches. So this is inches. Okay, so I could convert all of these. I could convert this into inches as well. I can multiply this by 12 and turn everything into inches and then turn everything back into feet to find my answer. But again, you can have different units as long as you line them up properly in a proportion. So I'm going to keep mine just as inches and feet. So I could either say this to this equals this to this, or I can go this to this equals this to this. It doesn't matter. I'll go 64. So I'll say 64 inches is to x feet. All right, these are proportional, is the same ratio, or excuse me, at same rate as 40 inches is to 50 feet. Okay, so when I find my answer, it'll just be in feet. Now, because I have 40 over 50, I could simplify that to be 4/5. I'm just going to drop the units just so I can see it a little bit easier. 4/5 divided by 10 over 10. All right, let's go ahead and cross multiply. 64 times 5. Let's see, 60 times 5 is 300, right? Because 6 times 5 is 30. 60 times 5 is 300. 4 times 5 is 20. So 320, right? 64 times 5 is 320 equals 4x. And I divide both sides by 4. And let's see, x is going to be, well, 32 divided by 4 is 8. So 320 divided by 4 is 80. And I always want to make sure, what was my units again? Was that inches or feet? It was feet, 80 feet. So my choice is choice C. All right, so that was a problem that we only were able to set up because of AA similarity. So AA similarity is your lesson for today. Go ahead and work on the homework.